Hi everyone, this is Taha Falatouri. On behalf of my team, I'm happy to present the finding of a work package of a large research project conducted in research field of data analytics and foresight at the Department of Logistics at the University of Applied Science, Upper Austria. The project partner is one of the main retailers in Austria with stores all across the country. The project aim is to implement data analytics in retail supply chain. Predictive analytics in supply chain management has received growing attention over the last years, especially in retail supply chain. Volatile customer demand, fierce competition, and complex global supply network structure require efficient process and data-driven decision. Particularly in high potential of applying predictive analytics in retail supply chain is seen in the context of demand forecasting. Accurate and sophisticated demand forecast enables informed decision in inventory management, purchasing, assortment planning, and ultimately ensure product availability at the point of sale. Decreasing fulfillment time force companies to utilize new technology and advanced analytics in Industry 4.0 era. Huge amount of data is generated and provided by these technologies, which in turn allow for increased data utilization and exploitation to make data-driven decisions. Especially in the context of demand forecasting in Industry 4.0, this represents an essential opportunity. Answering the question of which method best suits available data in a given context remains a challenge for practitioners and researchers. To answer this question, we have conducted current research to find out how do selected predictive analytics approach for forecasting the demand of fruit and vegetable in grocery retail perform in the term of forecasting quality. In order to have a better understanding of previous studies, we have conducted a comprehensive literature review to understand the methods and factors of forecasting. Many retailers still conduct manual forecasting based on their experience to predict product demand level for the next day. However, besides being time-consuming and strongly depending on the individual experience and bias, that approach may not always be trustable due to dependency of customer demand on many external factors, such external factors can be controllable like price variation, substitution, and cannibalization, or uncontrollable like holidays, season, and weather. Regression-based method, time series, artificial neural network, and other methods has been utilized in the previous years' research. The abundance of forecasting methods shows that vast range of their applicability in different areas. It has to be mentioned that it is not possible to record or calculate the real customer demand in food retail store because the customer cannot place order and can only buy actual available products. The employed data is related to cashier data of 4 perishable products sold in more than 90 stores of the selected region of a leading retailer in Austria. It is laid on fruit and vegetables. The sale level of the most purchased vegetables in subgroups of tomato, potatoes, salad, and cucumber over a period of 3 years from January 2017 to December 2019 were selected as the databases for the paper. Figure illustrates the historically daily sale of these 4 products. Significant sale peaks are mostly related to the promotions. Hence, for days with missed sale value, we tried smoothing the noises and replace missing data with simple arithmetic average method. We have selected the most popular forecasting methods in literature, SARIMA and LSTM. The main limitation of SARIMA is its inability in considering outlying data caused by external variables. To answer this problem, SARIMA-X has been proposed by researchers. SARIMA-X is SARIMA model with external parameters. The other method is LSTM, long-term short-term memory. Is type of RNN that can keep information in line memory from sequential observation. This method describes properties of data without any prior knowledge of parameters and distributions. The independency of this method to the parameters makes similar adjusting to the complex and nonlinear series. The black lines shows the real data sales and colored lines shows the results related to SARIMA, SARIMA-X, and LSTM in the figure. You can see in this picture that SARIMA-X has better result by considering the external factors such as promotions. Look at here and here and even here. To evaluate the reliability of each model, MAP and RMSE have been calculated. To have a more precise evaluation, we conduct the evaluation on the test part of the dataset. The comparison of actual sales of the 3 years shows that the accuracy of SARIMA and LSTM are close to each other for the selected product, salad and tomato. However, the performance of SARIMA is significantly better for cucumber and contrary-wise for potato, for which LSTM produced better results. To identify possible reasons for this result, we look at the historical sale behavior of the selected product. Historical sales data for potato and salads shows more steady trend and are free of intensive noise. For products with these characteristics and a stable behavior, our results reveal that LSTM model can provide good prediction result, which in line with the literature. Regarding the forecast accuracy for tomato, the MAPE is much higher than for the other products. At first glance, we find out that the tomato sales level didn't follow its historical trend in January 2020, and we only analyzed the top selling type of tomato. A wider variety of tomato types in 2020 could be one source for this weird behavior. For example, similar organic products in this product group have been observed in the cashier data sets, which wasn't the case for the other 3 products. And the things I have to mention, we used the January 2020 data as the test data for our models. I have forgot to mention it before. In the second step of our analysis, we tried to implement SARIMA-X model in order to consider promotion days as an external factor. The results are satisfying, and we experience a big improvement in the accuracy of prediction compared to normal SARIMA model. However, these improvements are not similar for our product. As it is observable in the table, the improvement via SARIMA-X is highly correlated to change of daily sale average in promotion days, where we experience a significant improvement for salad and tomato, where the improvement was 53% and 54%. In contrast, the moderate improvement of potato result 28% may be related to the lower correlation of potato sales and promotion days. In addition, there were no promotion days for this product during January 2022, and the model was not able to show its advantages in this period. For cucumber, the results showed an even lower improvement, about 12.5%, by adding the external factor of promotion days. Possible reason for that could be an unidentified degree of dependency between cucumber sales level and other external factors like holiday or substituted products, which could be higher than for other three products. In summary, SARIMA X result improved demand prediction for salad from good to highly accurate, for tomato and potato from reasonable to good, and from cucumber demand prediction, the forecasting quality improved and stayed at the level of good forecasting. The result of this paper can improve the profitability of business by increasing the sale number and decreasing the amount of waste products based on the usage of complex method of forecasting. The improvement forecasting model can be used by businesses to optimize their inventory level, increase their bargaining power for purchasing, and ensure product availability. In context of Industry 4.0, advanced demand prediction represents an important prerequisite and enabler. Various papers have been already dealt with this issue and at the intersection of the Industry 4.0 and demand forecasting, and found huge implication in the context of energy demand prediction and energy saving, demand prediction and automated warehouse management, demand prediction based on product tracking and customer feedback, or demand prediction based automated purchase order and production. So all in all, thank you for your attention. I would be happy to hear your comments. Thank you. Bye.